I have a bit of a problem. Yeah, I've got a bit of a problem. For some reason, I've been talking a lot about logistic regression lately and teaching classes that use logistic regression. And the problem that I keep running into is that it's hard. It's really hard. It's hard to make sense of logistic regression. And I think the reason why it's hard to make sense is because I don't think the tools that we have are very good, particularly the visualization tools. And let me show you what I mean on my iPad. By the way, this is totally unscripted, what I'm about to show you. So I reserve the right for this to suck. Okay, so you've got to plot. So if we're doing standard regression, it looks like something like this. And then you have a regression line. And we can evaluate the fit of the model by how well that line passes through the data. And that is super intuitive to me and to my students. And so if you've got a line that looks like that, you know something's wrong with the model. The problem is logistic regression doesn't behave that way. In fact, the line never passes through the data. Let me show you what I mean. So with logistic regression, you have a bunch of ones up here and zeros down here. And so your curve is going to look something like that. And that curve never ever passes through any of those values. And think about that. That makes sense because like the values are ones and the regression line will never predict 100% probability that you'll be a 1. So it never even touches the data. So how do you do that? How do you visualize that? How do you evaluate from a plot if the model is right? And what I've done in the past is I've just said to students, somewhat embarrassed, I just say, yeah, kind of ignore the data and just look at the line to see if the model fits. And if the line has a steep slope, then it fits. If it doesn't, then it doesn't fit. And I've never been satisfied with that. So I don't like I will avoid logistic regression just because I can't see it. And so I guess I'm sick of feeling that way about logistic regression, that I can't see it. And as I was pondering that, I was also pondering my recent video about how this channel is going to change. That I'm going to start doing things that are more interesting to me and not so much make videos that fulfill a specific purpose. Yeah, totally being selfish with my videos now. But whatever. It's my channel. I can do what I want. And as I've been thinking about that, I've also kind of had in the back of my mind thinking, like, what excites me? What kind of videos am I excited to make? And I started to formulate an idea that maybe not all my videos, but certainly some of my videos can be of the sort where I don't know what's going to happen. I'm going to try to study something and try to learn something and try to accomplish a goal and bring you along with me. And honestly, that makes me a bit nervous because I may start out with like really grand ambitions, like visualizing logistic regression plots intuitively, and I might fail. In fact, there's not a small chance that I will fail, at least in some respects. I might hit a problem that I can't figure out. But you know what? There's YouTube videos that I watch where people do this, and ironically, like I don't ever watch stats YouTube videos. Like, that's my profession. Why would I want to wind down at the end of the day watching stuff about my profession? So I tend to watch a lot of like building stuff. And one of my all-time favorite YouTubers is Alex Steele. He's a blacksmith. And very regularly he does a series where he's like, I'm going to figure out how to forge titanium and steel together. Why don't you join me? And it's fascinating. And that particular problem is really difficult to work around. And it's very fascinating to watch this individual, Alex Steele, problem solve these things. And I thought, you know what? I think my audience might enjoy that. They might enjoy seeing the process of how I figure something out. or how I don't figure something out. Because again, I might screw this up royally. I might not be able to figure it out. And the other advantage of doing this sort of live research, not only do you get to see the process and how I might approach problems, but also I can borrow your expertise. I might, because I know there are people out there that know more about certain areas than I do. There are probably a lot of people out there that know way more than I do about everything. And they still watch my videos. I'm not sure why they would do that, but they do. And so if I can tap into your expertise when I run into a problem, that's cool. So yeah, with that being said, let me introduce you to the first of probably many in a series of, I gotta think of a cool name for this. Like live research. Oh, I'm gonna use ChatGPT. Stat happens. That's fun. Cold start. Stat scratch pad. That's fun. It's just hard to say. Stat scratch pad. Stats unscripted. Query in progress. I think we'll go with stats scratch pad for now. Ooh, exploratory everything. Explore everything. That's what I'm going to do. Explore everything. That's what the series is called. Welcome to Explore Everything. Insert cool title music sequence that I'll probably never get around to because I'm lazy. All right. Okay, so I'm going to start with the first idea that comes to mind for how to visualize this. So I will return to my plot. It'd be cool if I had like sophisticated animations, but I'm not going to because that's just going to interrupt the creative process. So my idea is if this is your X variable and this is your Y, which of course is binary, that we bin X's. So that'll be a bin, that'll be a bin, that'll be a bin, etc. And then what we do within each bin, and I'm going to add some data points just to make it a little more interesting. Within each bin, we're going to count the proportion of times you have a 1 versus a 0. And I still don't quite know what this is going to look like. So we've got 2 yeses and 1 0 there. And then maybe overlay like a bar chart that shows the proportion of yes. That looks like it's a little high. So something like that. And then maybe I'll shade it in just to make it look a little better. So we've got predominantly non-colored here. And then if we move into the next stats bin, we've got 3 and then 2. So it's got like 60%, so it's slightly less, something like that. And then the next one, it's about split even. And I have run out of room here. So something like that. And then the idea is, now, as I'm looking at this, I'm like, okay, that doesn't look like, it's still not passing through the center of the data, but that may just be because I drew a terrible ogive curve. So I'm going to try that. I have no idea how to code that. No, I kind of do. Okay, so let's think about what that would require. So we would, in order to do that in R, we would have to 1 bin X values. And of course, the plot will be sensitive. Yeah, that's going to be one of the problems with this plot. It still might be helpful, but if you choose to bin based on 10 categories versus 5 categories, you're going to have an issue. Okay? So we're going to bin the X values, and then 2, plot logistic curve, which will be easy because FlexPlot already does that. So I just have to use the existing FlexPlot function. And the cool thing about FlexPlot functions is they are ggplot objects. And the cool thing about ggplot objects is you could layer things. And all this is a layering. So 3 will probably require a new data set. So create new data set with bar chart data. And then for, once we got the bar chart data, then we overlay onto the plot. Okay. I'm going to try that. I don't know if it's going to work. I don't know if it's going to be helpful or not. As I said, I reserve the right to fail, like big time. In fact, there's a YouTuber that I watch, David Picciuto from Make Something. I watch a lot of building videos because I like to build. That's one of my hobbies. He has a phrase that I'm going to have to remember. I'm going to have to look it up. Everything is an experiment. I think that's his take on things. And I really like his approach to woodworking that, you know, some people, myself included, they get very tied up and wanting one specific outcome, wanting things to go well, and then if things fail, then they get frustrated. And the way that he tries to look at it is everything's an experiment. And if that failed, then that's cool. We learned something. Let's try to modify. All right, so I think I'm going to do that. So I'm going to pause the video and jump into R and see if I can make something. All right. See you in a bit. Okay, quick update. That was kind of successful, I think. So I'm going to step into R and show you what I got. All right, so I'm just doing a test plot right here that looks like that. So that shows the probability that somebody died given their agility levels in the final Avengers battle. And we've got the raw data at the top. And the final step is to overlay those bins atop the plot. And this is what we get. And it's kind of cool. So this kind of sort of becomes like the top of the bars now represent the raw data. So if we're thinking about trying to have a plot where the line passes through the center of the data, now the center of the data becomes the bars. So then it's very easy to evaluate how well the plot is doing. And it looks like for this plot, like some of them, like for example, this line right here, the logistic curve is overestimating their probability of death. Whereas for this one down here, it's underestimating. And of course, right here, it's pretty significantly underestimating, but there's also not that many data points. So I'm liking this. What don't I like? Well, I don't know that I know very well what I don't like. Well, one thing that I don't like is that it's not conveying the sample size, because like these bars take up a lot of space, which, as I'm listening to my visual intuition, it's saying that's a massive outlier. But it's really only 2 data points here and 2 data points here. So it's not that big of an outlier. And yet it takes up so much visual space that it leads me to believe that that's a problem when it's not. So I'm thinking we ought to modify the bars so that they convey something about the sample size. And so probably what I'll probably use is transparency, that it'll become much more opaque when there's a large sample size. And I think that'll help convey it, I think. And then the other thing that I want to do, and I don't know why I want to do this. Well, I have an intuition of why. I don't know that I could explain it. But right now, all the bars start at 0 and go up. And so they're strictly positive. And I think it would be cooler and more intuitive if the bars start at the 50% mark. And so then those bars represent deviations from 50%. And so these bars would go all the way up to here, but then this one would actually, it would have a space right here. And I think that might be more intuitive to look at. In fact, there's a plot called a hanging rootogram. That I totally forgot about those. I learned about those when I was in graduate school. Like, what year would that have been? Like 15 years ago. So I'm going to work on that. And let's see what happens. It might be really cool, or it might be really lame. So we'll find out. It works! And that looks cool. Ah, that is cool. Okay. I'm quite delighted here. Okay, so we've now got transparency indicating how many data points are. And what's cool to me is that the logistic curve is really, really close to those bars where it matters, where the sample size is large. And then it gets progressively more off the farther away the sample size is, which is exactly what you would expect to happen. That is so cool! Ah, man. I want to frame that on my wall. That's cool. That actually worked! Wouldn't that be kind of lame if this was like a series and that was it? That was a solution? That was way too easy. That never happens in research. But there's still some more testing that needs to be done. So that was one plot. I ended up wrapping this inside of a function, which is right there, just to make things a little bit easier. And now I'm just gonna like play around with it and see, yeah, just see what happens. Because for this plot it looks really cool, but it might not look so cool for other things. So I'm gonna try just some other plots. Let's look at D, which used to be Avengers. So I don't remember which of these variables has the strongest relationship. You know what I could do is I'll just play around with a bunch of them. All right, died tilde. Let's try speed. See what that looks like. Okay. And oh, that's cool. Okay. And that's the sort of thing you should be able to detect with this, which is one of the goals that I had in the back of my head. I forgot to tell you about that. Let me explain on my iPad, because I can envision a situation where okay, so that's our new plot. I can envision a situation where, you know, it starts out like this and then it like flips. And then basically it's non-monotonic is what you would say. That monotonic means the second rank order is smaller than the third rank order, which is smaller than the fourth rank order, and it's always like that. And so in the first example that we saw, it was monotonic. So the bars always got smaller, or the proportion that died always got smaller as you increased agility, but with speed you got a little bit of a flip. Now it happens to be in a place where there's not that many data points, and that's the only reason it flipped. It's just because there's so few data points there. All right, so let's step back into R, but that's promising. That's looking good. That's looking so good. Okay, so we did speed. Let's do strength. Okay, and this is just working so well. Okay. I'm kind of bothered that... Okay, I'm going to make notes. I'm bothered that the bars overlay the line and not vice versa. So that should be an easy change, just to flip the order of those so that the line is on top. And the other thing that I was thinking about that was it might be nice, though too cluttered, to overlay another line that follows the bins. Or in other words, we draw a line from here to here to here to here to here. That might be cool, or it might just get things really, really cluttered, but I think it'd be easier to compare the regression curve to the actual probabilities. And I also need to investigate how bin size affects things. And it may be that there's an optimal bin size that, I've just been using 10 as a default. And it may be that the optimal bin size depends on your sample size. If you have 10 data points and you're doing 10 bins, that's going to be 1 bin per data point. That's not a very good idea, I don't think. So anyway, investigate how bin size affects things. an optimal bin size depending on n or the sample size. Yeah. Okay, let's keep going through this. So now we got damage resistance. Okay. And here's an example where you have non-monotonicity. So you got this bar, which is more negative than this one, but everything else is a gradual decay up until you get here. But again, that happens only when there is a small sample size. But that is working like shockingly well. And in some ways, I think you may not even need the individual data points if you got this. So maybe I'll say, maybe remove the raw data points because it's pretty redundant with the bars, especially since the bars communicate sample size information. Or shift the dots so they fit within the bars. So what I mean is, like, in this area, instead of them all being concentrated at the yes or no, that you allow them to spread out. Would that benefit you at all? I think that would just get messy, and I don't think that would add anything. So yeah, I'm just removing the raw data points, but I'm so happy this is working. Although I am noticing that my eye, it bothers my eye that the regression line isn't capturing these lighter areas, even though it doesn't have to. So I wonder if there's a... Okay. Okay. Let me go back to this idea. So instead of another line, or just dots, and then you can interpret it like a scatter plot. I think that might work well. Okay, I'm going to try that. All right, let's keep going and see what other insights we can glean. Now, this is a problem that I'm not even going to begin to address in this video. Like, what happens when you have two categorical variables you're looking at the relationship between, and that's complicated because I tended to use association plots, but they're not intuitive to me. So we're going to skip that for now and save that for another video. But we will go flexibility. And that's interesting. Okay. So it's really noisy. Like, it's monotonic and then it's not. So this would be a good example where it starts out monotonic and then it almost kind of goes back down. So in fact, the regression line should almost look like a normal distribution there. But regression lines are forced to go like this. Ooh, oh, I just thought of something. Okay, I'm going to try something. I'm going to try to model the relationship between flexibility and dyed as a polynomial, and I'm going to see if it captures that. All right, let's try that. Mod equals GLM dyed tilde flexibility plus I flexibility squared. Data equals D, family equals binomial. And then I'm going to visualize that. Mod plot equals model. Ha, look at that. And I learned this like a couple weeks ago because I was playing around with logistic regression. I thought, what would happen if you modeled a polynomial? And that's what happened. You get this kind of like bend in the middle, and then it goes back down, which I would not have called. I didn't know you could do that. And so if I could overlay that, I'm going to do some work in R, and what I'm going to do is I'm going to try to do two things. One, I'm going to change the logistic with bars function so that you can feed it an existing flex plot and just overlay the bars so that I could see what happens with when you overlay the bars like that. And then the other thing I'm going to do is work on some of these other things. So I shall be back, my friends, shortly. Well, for you, there's going to be no cut, but for me, there is.
Sunburst what it earned, but from the burns, it's evil love. What's that I see? I think it's blind. What's the feeling down in me?
Oh, I've been recording this whole time. Okay. Okay. I have figured those two things out, so I'm trying to remember what I wanted to do. All right, I'm going to look at this again. I don't remember what I was going to show you, but I'll just show you what happens. Oh, it looks like I forgot to overlay the line on top of the other, on top of the bars, but I did add dots, and so these dots, the sizes represent the proportion, and the transparency represents a proportion. I don't know that you need both, but why not? Might as well have it. And that is like beautiful. Actually, you know what? I don't think I want transparency to do it because it's hard to see these other dots. So I think I'm going to change that so that it's just size. It's indicating the sample size. Maybe. All right, so now I'm going to see what happens when I change the bin size and see how that affects things. So how big is my data set? nrow data, or D, 800. So let's try 30 bins and see what happens. I love it. And it just like communicates what logistic regression is doing. It's not trying to fit the tails. It's trying to fit the center of the data, which is what all statistical models do. But this like really illustrates it. Yeah, I'm going to remove the transparency, and that'll be easy to do. So point alpha, let's do that. All right, cool. And if I do that now, then the dots stay transparent, and then just the sample size is indicated by the dot size, which is great. This is fantastic. So now if I shift it to 30, that's great. Let's try to average a sample size of 10. What did I say? nrow divided by 10. Let's try 80 bins. See what happens. Oh, it is so beautiful. Ah, it's working. Okay, I kind of like more bins. I'm sure there's going to be a limit to it, though. Let's go like 800, and then it's just going to get super noisy. Oops. Oh, did I do it? It didn't seem to do much different. 100. Yeah, I don't know what that's doing. But it'd be interesting to try it with a smaller sample size. But that is really cool. I'm excited about that. All right, so can it really be this easy? There's still some other things I want to try. I think this is working like shockingly well. It's probably going to have a issue if you have a small sample size, though. Let me just try that real quick. There's a data set that I use in FlexPlot just for testing purposes. If I go ahead, small, just a very small data set. And then if I go, let's see, y underscore binary tilde x data equals small. Let's see how that looks. Okay. Okay, I did realize a potential problem with this is like it doesn't communicate the sample size clearly, so I might actually put the original dots back in at the top and the bottom. But this is like super promising. This is working really well. This is great. So, what was I gonna do? Like I said, I did not intend for that to work so well, but it really did. I had like several ideas of what I was going to try, because I assumed this would like work maybe okay, but have like major problems that some of the other methods might address. But it just works really, really well. But I still want to try some of the other methods that I have in mind that are a little more sophisticated. And I'm going to try those. And so, yeah, I think in the next video, I'm going to continue on this trajectory. And by the way, all these things that I am building are going to be available in FlexPlot when I get around to it. So you have that to look forward to if you are a FlexPlot user. And if not, then you should be, because FlexPlot's amazing. So anyway, that's all I got to say for now, except take a simplistics class. I'm starting one in just a couple of days. So by the time I publish this video, which I think is going to be tomorrow, today's Wednesday, tomorrow's Thursday. So by the time I publish this video, I won't have that many days until my simplistics class starts. And there's still a few slots. So make sure to join me and I can teach you about data visualization, because that's a big component of the simplistics class. But anyway, I'll see you next time. Peace out. My hair don't stay in place when it's long and there's a rut.
Excuse me, sir. Can I just ask a question? I want to know, how do you do statistics? Yes, I don't want to do a class. I just want to have the information downloaded to my brain.
I can't do that. I can't know how. Wow, wow.
Well, if you just take some time to learn, you know, stats can help you in everyday life. You know, you can know the probability of anything.
It's a very common question where people are like, "Oh, you're a statistician. Do you like tell me what is the probability it's going to rain today?" I'm like, "Look at the weather app. That's not like all statisticians do." And to make those inferences, they need to have the data. They just don't know that stuff off the top of their heads. That's ridiculous. I got a dog in the background making a noise. What's the problem there? Excuse me, Professor. You have to like really bend your brain to something. It's better to look at a plot, but even the plots are...
Oh, you can't do that. You'll go to hell.
Alright, I'm about to record a video. It's like good, I hope.